End of year exam, June 2023, paper 1 for Maths AA standard level. Question 1. Solve the equation 2 natural log x is equal to natural log 9 plus 4. Give your answer in the form x is equal to p times e to the power of q, where p and q are positive integers. First, rewrite the equation as 2 natural log x minus natural log 9 equals 4. Spot that 2 log x can be written as log x squared minus log 9 equals 4. Now use the quotient rule, so we get log x squared over 9 is equal to 4. That means that x squared over 9 is equal to e to the power of 4. Therefore, x squared is equal to 9e to the power of 4. Therefore, x is equal to the square root of 9e to the 4. Therefore, x is equal to plus or minus 3e to the power of 2. As x must be positive, therefore x is equal to 3e to the power of 2. Therefore, p is equal to 3 and q is equal to 2. Question 2. The nth term of an arithmetic sequence is given by un is equal to 15 minus 3n. 2a. State the value of the first term u1. To find the first term, substitute n equals 1 into the formula. Therefore, we get u1 is equal to 15 minus 3 times 1, so u1 is equal to 12. 2b. Given the nth term of this sequence is equal to minus 33, find the value of n. Therefore, we know that 15 minus 3n is equal to minus 33. Therefore, 3n is equal to 15 plus 33. Therefore, n is equal to 16. 2c. Find the common difference. We know that un is equal to u1 plus n minus 1d. We know that u16 is equal to minus 33, and we know that u1 is equal to 12. Therefore, minus 33 is equal to 12 minus 15d. Therefore, d is equal to negative 3. Question 3. A function f is defined by f of x is equal to 2x minus 1 divided by x plus 1, where x belongs to any real number and x cannot equal minus 1. The graph of y equals f of x has a vertical asymptote and a horizontal asymptote, 3a. Write down the equation of the vertical asymptote. Well, vertical asymptotes are found when the denominator, x plus 1, is equal to 0. Therefore, x is equal to minus 1. So the equation of the asymptote is x equals minus 1. Part B. Write down the equation of the horizontal asymptote. If we write the equation in the form ax plus b over cx plus d, the horizontal asymptote is equal to A over C, which is equal to 2 over 1. Therefore, it is y equals 2. 3C. On the set of axes below, sketch the graph of y equals f of x. On your sketch, clearly indicate the asymptotes and the positions of any points of intersection. First, let's put on our asymptotes. We've got x equals minus 1. So that is our vertical asymptote. We've got our horizontal asymptote. Y is equal to 2. Then we need to find our points of intersection. So we need the y-intercept and the x-intercept. Our y-intercept is found when x equals 0. So therefore we get y equals 2 times 0 minus 1 divided by 0 plus 1. Therefore y equals minus 1. Let's put that onto our graph. Y equals minus 1. Now, to get our x-intercept, we know that y equals 0. Therefore, we get 0 equals 2x plus 1 divided by 2x minus 1, divided by x plus 1. Therefore, we get 2x minus 1 equals 0. So 2x equals 1. So x equals a half. Let's put that onto our graph. X equals a half. Now we can draw our graph. As smooth as you can, going through our intercepts. And then nice and smoothly. So that is the graph of y equals 2x minus 1 divided by x plus 1. Question 4. A data set with n items. The sum of the items is 800 and the mean is 20. For A, find n. Well, we know that the mean is equal to the sum of the items divided by the number of items. So we get 800 over n is equal to 20. Therefore, n is equal to 800 divided by 20. So n is equal to 40. The standard deviation of the data set is 3. Each value in the set is multiplied by 10. Write down the value of the new mean. Well, the new mean is the old mean multiplied by 10. So that is 20 times 10, which is equal to 200. 4C, find the value of the new variance. Well, the old standard deviation was 3, so the new standard deviation is 3 times 10, which is equal to 30. But variance is equal to the standard deviation squared. So the variance new is equal to 30 squared, which is equal to 900. Question 5. Jim heated a liquid until it boiled. He measured the temperature of the liquid as it cooled. The following table shows its temperature in degrees Celsius and T minutes after it boiled. Write down the independent variable. The independent variable is always your input. The input here is T, which is time. 5B, write down the boiling temperature of the liquid. Well, you're told that it has boiled and then it starts to cool. So it is the initial temperature, which is 105 degrees Celsius. Jim believes that the relationship between D and T can be modelled by a linear regression equation. 5c. Jim's model is equal to D is equal to minus 2.24t plus 105 for t between 0 and 20. Use this model to predict the decrease in temperature for any 2-minute interval. Well, this is a rate of change equation. So dd over dt equals minus 2.24. That means for every minute the temperature decreases minus 2.24 degrees. Therefore, for 2 minutes it decreases 2 times 2.24 degrees Celsius, which is equal to 4.48 degrees Celsius. In this question, you would have got no marks for using the table. It wants you to recognize that the equation given is a rate of change equation, and you have to use that. A biased four-sided die with faces labelled 1, 2, 3 and 4 is rolled and the results recorded. Let X be the result obtained when the die is rolled. The probability distribution for X is given in the following table, where P and Q are constants. For this probability distribution, it is known that the expected value of X is equal to 2. 6a. Show that P equals 0.4 and Q equals 0.2. Because there are two unknowns, we need to generate two equations which we will solve simultaneously. The first equation we can generate is that we know that the probabilities add up to 1. We know that the probability of 2 is 0.3 and the probability of 4 is 0.1. Therefore, the probability of P plus the probability of Q, so P plus Q must equal 0.6. We're also told that the expected value is equal to 2. Therefore, we know that P plus 0.6, which is 2 times 0.3, plus 3Q plus 0.4, which is 4 times 0.1, is equal to 2. Therefore, I know from the first equation that P is equal to 0.6 minus Q. Therefore, I can substitute that into the second equation, so I get 0.6 minus Q plus 0.6 plus 3Q plus 0.4 is equal to 2. Therefore, I get 1.2 plus 0.4 is 1.6 plus 2Q is equal to 2. Therefore, 2Q is equal to 0.4. Therefore, Q is equal to 0.2. Substituting Q equals 0.2 into the first equation, I get P plus 0.2 is equal to 0.6. Therefore, P is equal to 0.4. Therefore, Q equals 0.2. P equals 0.4. Proved. 6b. Find the probability that x is greater than 2. Well, the probability that x is greater than 2 is equal to the probability that x equals 3 plus the probability that x equals 4, which equals 0.2 plus 0.1, which is equal to 0.3. Nikki plays a game with this four-sided die. In this game, she is allowed a maximum of 5 rolls. Her score is calculated by adding the results of each roll. Nikki wins the game if her score is at least 10. After 3 rolls of the dice, Nikki has a score of 4. 6C. Assuming that the rolls of the die are independent, find the probability that Nikki wins the game. In order to win the game, Nikki must get a score of 6, 7, or 8 with the next 3 dice. So you need to calculate the probability that the score is equal to 6 plus the probability that the score is equal to 7 plus the probability that the score is equal to 8. The probability of 6 is equal to the probability of a 2 and a 4 plus the probability of a 4 and a 2 plus the probability of a 3 and a 3, which is equal to 0.3 times 0.1 plus 0.1 times 0.3 plus 0.2 times 0.2, which is equal to, when you work it out, a score of 0.1. The probability that she gets a 7 is equal to the probability of 3 and 4 plus the probability of 4 and 3, which is equal to 0.2 times 0.1 plus 0.1 times 0.2, which is equal to 0.04. The probability of 8 is equal to the probability of a 4 and a 4, which is equal to 0.1 times 0.1, which is equal to 0.01. So winning is equal to 0.1 plus 0.04 plus 0.01, which is equal to 0.15. David has 2 pairs of unbiased 4-sided dice, a yellow pair and a red pair. Both yellow dice are labelled 1, 2, 3 and 4. Let S represent the sum obtained by rolling the 2 yellow dice. The probability distribution for S is shown below. S could equal 2, 3, 4, 5, 6, 7 and 8, and the probability that S is equal to S is for 2 is equal to 1 over 16, 3 is equal to 2 over 16, for 4 is equal to 3 over 16, 5 is equal to 4 over 16, 6 is equal to 3 over 16, 7 is equal to 2 over 16, and 8 is equal to 1 over 16. The first red dice has the faces labelled 1, 2, 2, 3. The second red dice has faces labelled 1, A, and B, where A is less than B, and A and B are positive whole integers. The probability distribution for the sum obtained by rolling the red pair is the same as the distribution for the sum obtained by rolling the yellow pair. 6D. Determine the value of B. In order to do this, I'm going to draw a sample space for the two red dice, which is as follows. Because the probability distributions are the same, we know that the probability of getting 8 is 1 over 16. Therefore, 3 plus B must equal 8. Therefore, B is equal to 5. 6E. Find the value of A, providing evidence for your answer. Well, looking at the probability distribution for the yellow dice, we know that there are 4 ways of getting 5. Now comparing it with the two red dice, we know that 2 plus A appears 4 times, so 2 plus A must equal 5. Therefore, A must equal 3.